Assalamu alaikum. My dear viewers, have you ever wondered how drones can capture detailed images or how weather forecasts are so precise? The answer lies in sensing technologies. Sensing technologies, in their most basic form, are tools that help us perceive the world around us in ways that go beyond the capabilities of the human senses. They're like an extension of our senses, enabling us to see, hear and feel things we otherwise couldn't, and they play an integral part in our everyday lives. Imagine you're trying to navigate your way through a dense forest in pitch darkness. It would be nearly impossible, right? But equip yourself with a thermal sensing device and suddenly you can see the world in a new light, literally. The device detects heat emitted by objects and creatures, allowing you to navigate your way safely. Or consider a meteorologist trying to predict the weather. Without sensing technologies, they would have to rely solely on visual observations. But with the help of microwave sensing, they can measure atmospheric conditions like humidity and temperature, even in remote areas, making their forecasts more accurate. And then there's hyperspectral sensing. This technology captures and processes information from across the electromagnetic spectrum. It's like having a super-powered camera that can see things invisible to the naked eye. Researchers use it to study everything from the health of crops to the quality of air we breathe. But why are we talking about these three types? Well, while there are many different kinds of sensing technologies, these three, thermal, microwave and hyperspectral sensing, are among the most widely used and versatile. They have applications in a variety of fields, from agriculture to meteorology, from environmental science to military operations, and much more. Now, this might seem like a lot to take in, but don't worry. We're going to break it down one by one. We'll explore how each of these technologies works, how they're used and why they're so important. Now that we've established what sensing technologies are and why they're important, it's time to delve deeper into each one. Okay, imagine being able to see the world through the lens of heat. That's precisely what thermal sensing allows us to do. Now let's delve a little deeper into this fascinating technology. At its core, thermal sensing is all about detecting and measuring temperature differences. It's like having a sixth sense that allows you to perceive heat emitted or reflected by objects, even in complete darkness. To understand how thermal sensing works, we need to think about the energy that all objects emit. You see, every object, whether it's a human, a tree, or a cup of coffee, emits thermal energy or heat. This energy is invisible to the naked eye, but not to a thermal sensor. The sensor absorbs this energy, converts it into an electrical signal, and voila! We have a visual representation of the thermal energy around us. Now, you might be wondering, well, that sounds impressive, but how is it useful? The applications of thermal sensing are as varied as they are numerous. Imagine firefighters navigating through smoke-filled buildings, able to see the heat sources and people trapped inside. Or think of wildlife researchers tracking animals at night without disturbing their natural behaviors. Even in everyday life, thermal sensors are used in home security systems to detect intruders or in cars to help drivers see obstacles in the dark. But let's clear up a common misconception while we're at it. Thermal sensing doesn't allow us to see through objects. Rather, it enables us to see the heat energy that an object is emitting or reflecting. So no, you can't use a thermal camera to see what's inside your Christmas presents. Thermal sensing is a powerful tool that offers us a unique perspective on the world. It's not about replacing our natural senses, but enhancing them, providing us with information that we wouldn't otherwise be able to perceive. So, as you can see, thermal sensing has a wide range of applications and offers a unique perspective on the world. Next up, we have microwave sensing, a technology that can penetrate through walls and see in the dark. Now, let's delve into the fascinating world of microwave sensing. This technology works by emitting microwaves, a type of electromagnetic radiation, and then detecting the waves that bounce back after hitting an object. This is similar to how bats use echolocation to navigate their way around in the dark. The information gathered from the returned waves can then be used to determine various characteristics about the object, such as its distance, size, and composition. But what sets microwave sensing apart from other sensing technologies? Well, microwaves have a unique property. They can penetrate through many materials that are opaque to visible light, such as walls, fog, and even vegetation. This is why microwave sensors are often used in radar systems to detect aircraft or ships through clouds or at night. Moreover, microwave sensing is not affected by lighting conditions. Whether it's the middle of the day or the dead of night, microwaves can operate just as efficiently. This is a significant advantage over thermal sensors, which rely on heat signatures and can be less effective when temperatures are similar between objects and their surroundings. And let's not forget the myriad of practical applications for microwave sensing. From weather forecasting and climate research to security systems and autonomous vehicle navigation, the uses are virtually endless. For instance, meteorologists use microwave sensors to measure temperature, humidity, and precipitation levels in the atmosphere, providing valuable data for weather models and climate studies. In the realm of security, microwave sensors can detect movement through walls, offering a stealthy way to monitor an area without the need for visible equipment. Similarly, in the field of autonomous vehicles, microwave sensors can help detect obstacles and navigate through challenging driving conditions, enhancing safety and efficiency. So there you have it, microwave sensing. A technology that's as intriguing as it is versatile. It's a tool that sees the unseen, pierces through the darkness, and provides us with invaluable information about our world. With the ability to see through obstacles and operate in any lighting condition, microwave sensing is indeed a marvel of modern technology. Last but not least, let's delve into the realm of hyperspectral sensing, the technology that can see beyond the visible spectrum. Hyperspectral sensing, in its simplest form, is a method that captures and processes information from across the electromagnetic spectrum. It's akin to having eyes that can see light beyond the rainbow colors we usually perceive, from ultraviolet to infrared and beyond. Imagine you're looking at a painting. With your human eyes, you'd see a blend of colors and shades. But if you were to view the same painting with a hyperspectral sensor, you'd see a vast array of information invisible to the naked eye, such as the different materials used in the painting, or even the presence of an older painting hidden beneath the current one. This paints a vivid picture of the power of hyperspectral sensing. But how does it work, you ask? Well, hyperspectral sensors work by splitting the light reflected off an object or area into hundreds of spectral bands, far more than the human eye or even traditional cameras can capture. Each band represents a specific range of light, and together these bands form a hyperspectral cube, a three-dimensional representation that provides a unique spectral signature for every pixel in the image. And what's more, hyperspectral sensing isn't confined to art analysis. Its applications are as diverse as they are transformative. From agriculture, where it can detect plant diseases before they become visible, to environmental monitoring, where it can identify pollutants in bodies of water, to space exploration, where it can help identify the composition of distant celestial bodies, hyperspectral sensing is truly revolutionizing our understanding of the world and beyond. Here's the real magic. As technology advances, the potential uses for hyperspectral sensing continue to expand. It's not just about seeing the unseen now, but about predicting and influencing the future. This is the power of hyperspectral sensing, the magic that allows us to see beyond, to understand more, and to create a better tomorrow. Hyperspectral sensing, with its ability to capture a wide range of spectral data, has immense potential for revolutionizing various industries. We've traveled through the fascinating world of sensing technologies today, learning about thermal, microwave, and hyperspectral sensing. We've seen how thermal sensing, like a whisper in the night, silently observes the heat radiating from objects, revealing hidden patterns invisible to the naked eye. Then we dove into the realm of microwave sensing, a technology that pierces through clouds, darkness, and even solid objects, unveiling the unseen. Finally, we reveled in the magic of hyperspectral sensing, a symphony of light and color, capturing data from hundreds of narrow bands across the electromagnetic spectrum. Each of these technologies, each of these windows into the world, holds a unique value, a distinct perspective. They reveal the hidden, the unseen, the overlooked. They are our eyes in the dark, our insight into the unknown. Remember, these sensing technologies are not just high-tech jargon, they're tools that help us understand and interact with the world in ways beyond our natural abilities. Thanks for watching, subscribe to Quest, and stay tuned for next upcoming content.